Claxon's Algebra 1 class. I'm coming at you here with a review from the high school, a review for our test where we had to convert minutes to hours. We had to solve problems as well involving distance, rate, and time. We also had to factor numbers down all the way down to their prime factorization. And we also had to simplify rational expressions. So that's what I'm going to be reviewing today. You can see right here, to get it started, I'm going to try to make this very quick. We see this problem right here, to convert from minutes to hours. To convert from minutes to hours is really quite simple. Converting from minutes to hours, we divide the number of minutes you're given by 60. Some people can't remember this. They find it difficult to remember. The people who find it difficult to remember, I'm going to go ahead and point you to my way of doing it here. You start with your given, 52 minutes over 1. You're going to multiply. What do you want to cancel? You want to cancel the minutes. So write minutes in the denominator of the next factor. What do you want to convert minutes to? Minutes to hours. Do you know how many minutes are in an hour? Well, I should hope that you would know how many minutes are an hour. How many minutes are in an hour, rather. There are 60 in 1 hour. Multiply straight across, and look at what you're going to get. You're going to get 52 over 60, or 52 divided by 60. Hours. Now, obviously, that isn't finished. You would need to divide that, and pay attention to what I want you to round to as well. You would need to divide 52 divided by 60 in order to get the decimal form of that. I'm going to go ahead and leave that to you. Since you're following along at home, you can pause and do that if you would like. Once again, we have converting 2 minutes to hours. Converting 2 minutes to hours, you know, just divide 2 minutes by 60 minutes. That's the short way. This is the long way up here. This one, number 3, is a little bit different. It takes a plane 4 hours and 50 minutes to travel from Maine to Oregon. We want to convert this time into hours only. Well, I already have part of it in hours already, at 4 hours. The 50 minutes would be the only unit there that I need to convert to hours. In which case, I know that I can divide 50 minutes by 60. And I'm taking the 4 hours, and I'm going to add 50 divided by 60 to that. 50 divided by 60 is 0.83 repeating. So I'm adding 4 plus 0.83 repeating to get 4.83 repeating. And that's going to round to about 4.8 hours. Moving along, you also might have to convert from feet per second to miles an hour. You will have to convert from feet per second to miles per hour. I really want you to start thinking about the the formula that we learned in class, distance equals rate multiplied by time, and that can be manipulated by solving for r. When I solve for r, I divide by t on both sides. I'm going to end up getting r is equal to distance divided by time. As you can see, I've started this problem already. There are 2 different ways to do it. The first method that I'm going to talk about involves delegating, or breaking the problem down, break the problem down into an A and a B. What I want to do first is just figure out the rate in feet per second. Let's make this easier on the eyes. It's traveling 4 feet, that's my D, 4 feet, in 2 seconds. So 4 feet in 2 seconds, well, what's that the same as? That's the same as 2 feet in 1 second. 2 feet per second might sound a little better to you. However, I didn't tell you to convert the marble speed from feet per second to miles per hour. We're going from feet per second to miles per hour. Please excuse my handwriting there. My handwriting with this tablet is not the best. It's kind of sticky. The pen sticks sometimes, and it's really tough to make letters. So anyway, we start with what we're given, or actually what we calculated. Down here we'll start with what we're given. So we start with what we calculated. I know that I want to cancel out what? What do I want to cancel out? Ask yourself that question. What do you want to cancel? You should have answered either feet or seconds. You could do either or. I want to cancel feet. Well, what do I want to convert feet to? I want to convert feet to, well, let's see, feet doesn't convert to hours, so I want to convert feet to, let's see, what do I want to get to? Oh, I want to get from feet to miles. Oh, it tells me right up here, feet to miles. So feet to miles, there we go. Well, we all know, or we should know by now, how many feet are in a mile. Okay, so you would write 5,280 feet in 1 mile. And then what do I want to, so once I cancel out the feet, what do I want to convert? I want to convert seconds. What do I want to convert seconds to? Let's see, oh, seconds to hours, right there. Tells me, right there, because I set up my problem. So convert seconds to hours, I want to cancel seconds. So I would put seconds in the numerator, and then hours in the denominator. And this one gets a little tricky. Some people don't like to remember this. They always mess this one up. How many seconds are an hour? Well, if there are 60 seconds in a minute and 60 minutes in an hour, 60 times 60 is 3,600 seconds in an hour. Multiply the numerators, multiply the denominators, divide those two values after you multiply. You could also start, you could do this another way without breaking it up into two parts. You could just convert 4 feet per second to miles per hour by doing the exact same thing we did up here. You're going to have the exact same conversion factors and the exact same numbers that we talked about up here. You know that you're going to have feet in the denominator here, miles there, seconds, 3,600 seconds in 1 hour. All right, moving along. What I'm trying to get you to do is write down what formula you need. If you can see that right here, if you can identify what formula you need, you're going to be just fine. And if you'll remember, we did that. In all of the notes, you know, we were able to do that in the notes. In the notes, I asked you some questions. We went through a very, very defined process called UPSC. Understand the problem, plan for a solution, solve the problem, and then check your answer. Okay? In the understanding of the problem, you want to identify what it's asking. So you want to identify what the question is asking. What is the question asking? When you identify what the question is asking, I want you to underline it. What is the basketball player's average rate of speed? It's asking me for the rate, so I know I'm going to use the rate equal to the distance divided by the time. At this point, I just have to find the distance. Well, find the distance. Oh, yeah, here it is, 160 feet. That's D. Find the time, T. Divide those two values. That's going to give me an answer in feet per second. I might not like feet per second. I might want to convert that to miles per hour to better understand it. Or to, you know, if you want to tell your grandma how fast they were running, she might like miles per hour a little better. Right here, you can pause to look at this if you want to, but setting this problem up, how long would it take? I know how long would it take means I need the time. Time is equal to, and you would go back to our original definition of D equals RT. Well, if I divided each side by R, okay, then I'm going to get distance divided by rate. Time is equal to distance divided by rate. How much distance has the car traveled? How much distance? D equals RT. Really easy one to deal with there. In looking at some of the tougher problems, 13, 14, and 15, they aren't broken down for you. And this is where it's going to get kind of tricky for you, because you first want to find the rate before you figure out how far the plane or the person or the object would travel. The first thing you want to do, figure out the rate. How fast is the plane traveling? If it's traveling 480 miles in 1 hour and 50 minutes. So that is pretty fast, right? That is pretty fast. Well, you know, we want to find out how fast. So in order to do that, we need to convert this time. And you either need to convert it to all minutes or all hours. In this case, we're converting it to minutes because we want to know how far the plane would travel in 10 minutes. In 10 minutes? Okay, so if we get miles per minute, then we know, if we can calculate the miles per minute, then we know that all we have to do is multiply that by 10. So I'm going to go ahead and pause, calculate that for you, just so you can see what this problem looks like. Okay, you can see that we're going to get 480 miles in 110 minutes, which is exactly 4.36 repeating miles per minute. So that's exactly that. That rounds to about 4 4/10 miles per minute. 4 4/10 miles per minute. Remember, that's the estimate there. Traveling at that rate for 10 minutes means we're going to multiply by 10. Where does our 10 come? Our 10 comes from up here. That's our new time. I understand there was a time up there. We were using that to get the rate. We were just using that to get the rate. 44 watt. Many students struggle to put the units. 44 watt. What were we trying to answer? We were trying to answer how far. And we look back here. We were measuring in miles, so 44 miles. All right. Polish that off by circling it. You have now answered the problem. You have now answered the problem. Understand, that's a rounded answer. I really should have waves in front of that, because that's about 44 miles. The exact would be 43.6 and then 36 repeating miles. So you can see what the rounded, how far off that's going to make you. Just remember, two-part problem. Figure out the rate first, then use the rate to determine the distance. For some of the other problems, divisibility, when given a calculator, you're just going to plug the number into the calculator and divide it by each number. Now this is the long way. That's not the shortcut, dividing it by each number. That is the long way. Remember, for example, I'm testing 1,265,313. Is that divisible by 2? Well, you should know that it's not an even number, but divide it by 2, and you're going to see a decimal after there. Because you see value after the decimal place, you know it's not divisible by 2. Well, how do I figure out if it's divisible by 3? I could go through those very same steps that I just did, but you know what? Let's try the shortcut here. Let's go ahead and add 1 plus 2, that's 3, plus 6, going to get 9, plus 5, it's going to be 14, plus 3, 17, plus 1, 18, plus, see how that sticks there? 3, 21. So that's equal to 21. The divisibility rules state that if the sum of the digits is divisible by 3, then you know that that number is in fact divisible by 3. So 21 divided by 3, you know that is 7. Nothing after the decimal place there. So you know that this number, 1,265,313, is divisible by 3. I know it's not divisible by 5 because look at the last digit. It's not a 5 or a 0. The ones place does not have a 5 or a 0, so it's not divisible by 5. In order to be divisible by 6, it has to be divisible by both 2 and 3. And it is not divisible by 2, so that disqualifies 6. And then 10, in order to be divisible by 10, the last digit has to be a 0. So you know it's not divisible by 10. This is only divisible by 3. And this is a test question, by the way, for those of you wondering. Identifying a monomial versus something that's not a monomial. It's a monomial if it has one term. So this has one term, so it's a monomial. This down here does not have one term. It in fact has 3 terms. Okay, with a constant on the end. How many terms are in this expression? Well, how many terms does it have? It's separated by subtraction, so it has 2 terms. 2 terms separated by subtraction. Next, got to go further down the line here. Identify the prime factorization. Prime factorization is something that students have been struggling with. To make a factor tree, we know that we start with 100, and I just want to come up with factors. Now you can go 2 times 50 if you wanted to. I, for one, would rather make a short fat tree. Love those short fat trees. So 10 times 10, and I know 2 times 5, and 10 is 2 times 5. So now I only take the prime numbers. 2 is a prime number. It is the smallest prime number. So 2 times 2 times 5 times 5. 2 times 2 times 5 times 5. Oh, there we go. This one right here, Mr. Claxton. This one is not, because the 10 is not broken down. The 100 is not broken down there, and the 10 and the 10 are not broken down. You're going to do the similar. You're going to do something similar down here with 21. However, okay, you have some variables also to write. That's x to the first, y times y times y, and z times z. But we all know that 27 breaks down into 3 times 7 as well. I should not be giving you this many test questions. In simplifying this expression up here with very big exponents, we know that we could write 10 to the 25th out. We could write 10 out 25 times. We could write 10 out 10 times. You're just going to cancel, go through and cancel. Well, how many 10s will be left in the numerator? You might be thinking, well, Mr. Claxton, there's going to be 15 left. Yeah, you can also just subtract. That is the law of exponents, to just subtract the exponents there. So 10 to the 15th over 1. Find the greatest common divisor of 45 and 100. 45 and 100, greatest common divisor. How do I find it? Oh boy, greatest common divisor. Well, the long way that I taught you is to list out all the factors of 45. So you would list out factors of 45 and factors of 100. Now, I'm not going to do that for you. I'm going to let you do that. But just ask yourself, what is the biggest number that both 45 and 100 are divisible by? Okay? So I do factors of 45, and then I do factors of 100. Now, that's the long way to do it. Understand, that is the long way to do it. You can also do it a shorter way. And I'm going to go ahead and abbreviate here. Just try to keep my time down. Factors of 100. So we could do that and list out all the factors. That would be the long way. Or we could make a factor tree and identify all the common factors that they share. So we could identify all the common factors that they share. We know that 45, would break down prime factorization-wise. It's going to break down into 3 times 3 times 5. And we know that 100 breaks down into, well, we just did that, didn't we? 2 times 2 times 5 times 5. Multiply all those common factors together to find the greatest common factor. Looking at this one here, to simplify this right here, what I need to do is write the prime factorization of 275, my squared, and the prime factorization of 22, my. You can see that this is an option down here, but that's not the answer. Okay, I set it up for you, but I want you to simplify it. I want it simplified. To simplify it, you actually need to cancel common factors. Cancel common factors. I call it cross-canceling. Cancel the m's, and I cancel a set of y's. What am I left with? 5 times 5 times y over 2. 25y over 2 makes A the correct answer. I hope you paid attention. I hope you do well on your test. Well, I did give you some questions, actually. In simplifying these right here, 55 over 85, I said, you know what, I'm not going to do that problem for you. But in simplifying 65 over 95, I would want to write this a different way. 65 can be rewritten as 5 times 13. You should know that both those are divisible by 5. And you have a calculator, so you could divide them both by 5. And then write 95 as 5 times, well, let's see, if I doubled 9.5, I would get, 19. So, I know that I could cancel common factors, and I'm left with 13 over 19. You're doing the same thing whenever you have variables. You're canceling common factors. I have the prime factorization of 5m squared. I have the prime factorization. I thought I had the prime factorization of 20m cubed, but look at that. Mr. Claxton, you left out a 5. That's right. Now, I wrote it backwards, but that's okay. I know that the 5s are going to cancel. A set of m's are going to cancel. Another set of m's are going to cancel. Now what do I have left up here? Well, I really have 1 times 1 times 1 times 1. So I know that's going to be equal to 1 in the numerator, and then 2 times 2 times m times y is just 4my. Okay. I hope you've enjoyed watching. I know it's been quite a long study session, but hopefully it'll pay off tomorrow.